Yes, my name is Paul Gosling. I cover the weeds and diseases for the cereals and oilseeds side of AHDB. And what we're going to do this morning, this afternoon, is just a quick run out through some of the services we provide to you as agronomists and as farmers as well, and also a little bit of a technical update on some areas. I'm not going to say very much about resistance. If you wanted to know about resistance, you should have signed up to this afternoon's resistance workshop. If you didn't do that, that was a mistake. Because resistance is very important, but you're all at the start of your career, so we won't dwell on your mistakes. So, what do we do as AHDB in terms of weeds and disease management? Well, we do quite a lot of efficacy testing on the fungicide side. We don't really do much on the weeds side. I'm going to talk quite a lot about that because we invest quite a lot of time and money in that. I said I wasn't going to talk about resistance, but I will mention our resistance monitoring. We also have a few decision support tools that will hopefully be able to help you as agronomists. We do some disease forecasting, and of course we do independent research. So I'm going to start with the disease management. Fungicide efficacy, we call it fungicide performance. It's one of our key areas of work that we do. It's independent evidence on the efficacy of new fungicides, largely new fungicides. This is not about programs, this is about testing individual actives, or in some cases products, where they're only available as products. And it's designed for you to take the information away and design fungicide programs. We don't do fungicide programs because obviously there's an infinite number of different programs you can have. So this work is very popular with levy payers. One of the main reasons it's popular with levy payers is because it's completely independent of any manufacturer or distributor. So we show all the information, warts and all. It's our second largest spend within cereals on the research side after the recommended list. We spend about £300,000 a year annually on these trials. And we trial all the leading products side by side. So perhaps some of the information you might get from manufacturers, we show their leading product against something that they know is not going to perform quite as well, but we share them all side by side so you can compare them all on an even and fair basis. Having said it's independent of the manufacturers, we do work with the manufacturers and so we can get products ahead of registration and trial them so that as soon as they're registered we can provide information to you and how they perform. Some of the manufacturers are a little better at providing those than others. Sometimes we get a lot of data, sometimes we perhaps only get the products a year before registration, so it varies a little bit. We've got a standard format, which is relatively easy to understand. I'll go through a little bit about how you interpret that format. And we have a unique long-term data set now. Some of these trials go back to 1994, and I'll address that a little bit later as well. So I'm just going to say a little bit about the design and management of it, just because it's a big piece of work. The whole piece of work as a whole is overseen by what we call the Fungicide Working Group, and that has people from ADAS, NIAB TAG, SRUC, Harper Adams, and also we collaborate with Chuggas, which is kind of a bit like cross between AHDB and ADAS over in Ireland, and they contribute data to it. Something a little bit wrong with the slide there. So the Fungicide Working Group provides the scientific input that backs it up. It decides on what products we're going to trial, because there's obviously more products than we could possibly trial all the time. Scrutinises data and develops the key messages. Our priority is to look at new chemistry. We do have some old chemistry in there as standards, and we do occasionally bring back an old product in if we haven't done any information on it for a long time. We think something might have changed with those products, but basically the priority is new chemistry. And all the data is analysed within AHDB. That means there's no monkey business going on. There's no kind of dropping trials which don't kind of favour one product to another. If it's valid data, it all goes in. On the cereal side, we test products at 4 different rates, at a quarter, half, full label rate, and twice the full label rate. Now, that is certainly not to say that there's any circumstances in which you should be applying more than a full label rate. It's purely because it helps us fit the curves. It's a statistical thing, so we go up to a double rate. It just makes the curve fitting easier. Some of the trials are done at growth stage 31, so T1 timing. Some are done at growth stage 37, 39, so T2 timing, just to give us a spread over the diseases, except for ramularia and barley, which we do at a booting stage, so 45 to 49. The Oilseed rape trials are slightly different. They're a little bit more close to commercial practice. So whereas the cereal fungicides only apply once, For oilseed rape, we apply twice. For foam and light leaf spot, it's a 2-spray program. For sclerotinia, it's a single spray. And for the oilseed rape, we do a quarter, half, 3/4, and a full label rate. We don't go above a full label rate. The reason for that is because some of the oilseed rape products have a PGR effect. So if you go above a full label rate, you start to get yield decline because you suppress growth. And even at a full label rate on small crops, sometimes you can see a yield suppression with those PGR effects. And this information is very commercially sensitive. I have the agrochemical manufacturers on the phone to me regularly because they're concerned about what we're going to show. We work with them closely to make sure they know what's coming, because this information is very commercially sensitive. They get very concerned about what we're going to show and how their products are going to stack up against other people's. So I'm going to spend a little bit of time going through the interpretation of the data. First, before I do that, I'm going to say a little bit about whether you should have confidence in this data, because as agronomists, you're almost certainly going to be involved in these trials. Certainly if you work for some of the larger agronomy companies, you're going to be doing these trials yourselves. You may be doing them with farmers. Why should you have confidence in ours as opposed to what you're doing? We have multiple trials for most of the disease we look at, and multiple years. We analyse them all together using state-of-the-art statistical techniques. We have external stats consultants that help us with that, so we have very high confidence in the data. We rarely show individual trial results because, as we all know, an individual trial can show something completely odd, which you wouldn't very often see in a commercial situation. We do occasionally show individual trial results to highlight something that might be slightly different about the season. Generally, we do multiple trial analyses. The yield data for oilseed rape we regularly show because, as I said, it's closer to commercial practice. The yield data for cereals we don't very often show. I won't say we never show it, but we don't show it very often because it's a single spray application. It's not a program, so you can get quite distorted messages from a single spray. So when you do see any yield information coming from this work, you have to bear that in mind. I've said we show all the data, warts and all, but if we have something that we think is a bit suspect, we will hold it back. So there was a product came to market a couple of years ago. We only had 1 year's data on it because that manufacturer would only let us have it 1 year before registration. And for one of the diseases, they said, we don't like this. We don't think it's showing the right results. So we said, okay, why do you think it's showing the right results? Oh, all our trials have shown it performs much better. Strange enough, they didn't want to show something showing worse than they thought it was going to do. So we said, okay, well, we'll sit on that data for a year. And we did. We sat on that data for a year. We got more data and then released it. But we will sit on data we think might be an outlier for various reasons, but we will eventually release it once we have more confidence in the data. So how do you interpret the outputs? This is what you will see in most cases. You'll see a dose-response curve. So I'm going to spend a little bit of time explaining how to interpret these. So what we have on the y-axis, we have disease, in this case, percentage disease, and we have our percentage of the full label rate. So here we are up to double the label rate. The points are the individual data points from the trials, and then we use statistics to fit curves through those. So these ones here, you can see we've got the black line and the red line and the blue line all fitting very closely to the points, so we can have high confidence that those curves are in the right place. We can see these two lines, the black and the red, are very close, they're right on top of each other, so those products are performing the same. But what about the blue line? Well, one thing we don't do with these sets of data is put statistics on them, which you may think is a little bit surprising. The reason for that is quite simple. When you've got multiple years and multiple trials, the statistics get very complicated. So you'll often see LSDs put on agriculture work. The problem is when you have different numbers of products in different trials, the LSDs are not the same when you're comparing two different products. So, for instance, comparing these two, the LSD may be different to comparing the red with the blue. So the statistics can be quite complex, so we don't put statistics on. We let you interpret. But so here, blue looks better than the red and the black, but actually, look at the difference. It's about a half dose, it's about 0.5%. So we could probably pull those apart with statistics, but actually, there's no meaningful difference there in terms of agronomy. They don't always look like this. Sometimes we have a situation more like this. So if we start with the dotted green line, we've got a very poor fit to the line. What does that tell us? It tells us we're not really sure exactly where that line goes. It's somewhere around there, but the fit is poor, so we're less confident. Lines crossing, again, we've got, here's our full dose rates. You could say, well, actually, this product does a little bit worse than that one, but actually the lines cross. The points are are swapping around. So again, you wouldn't really want to pull those two apart, and I very much doubt you'd be able to do it with statistics either. Situation's a little bit more tricky with these two. The dark blue line here, and the sort of orangey yellow point. Yeah, the points are a little bit more spread, certainly compared with here. But if you look at all the individual data points, the orange ones are always above the blue ones. So you can probably say that the blue one is actually doing a little bit better there. But there is a little bit of interpretation that has to go on with these. Once we put it in any sort of hard copy form, we clean it all up, we take off the data points, and we reduce it down to a full label rate, just to keep it nice and neat. So if you want to see the full data set, you have to come to one of our events, one of our agronomist conference. If you go anywhere else, you pick up a hard copy of anything, you will just see that sort of thing. The other bit of data that comes out of the cereal side, the wheat side, is we do some mycotoxin testing on our Fusarium trials. And this is the 2016 data, so the DON level, the maximum level is 1250. So here we have untreated, and then our products we had in tests that year, all of them reduced it below the maximum level for human consumption, and we got some kind of differences you'd expect with DON and Fusarium. And that's the other way you'll see data presented from these trials. Another output from these trials, and you won't be able to read this, but it doesn't matter, is what we call our star charts. And this isn't really intended for agronomists, this is more for farmers, because what it does is it gives active mixtures and the score they get against different main diseases. So here we've got fluxaperoxide and epoxychondrols, that's a Dexar and its related things, and the different scores it receives. So a higher score is a better score. So it gets a maximum score against Septoria, yellow rust, and brown rust. This is pretty crude because there's no relation to dose on these. It's really meant for people who are perhaps not so familiar with some of the products, not familiar with some of the diseases, probably not aimed so much at agronomists, more of a farmer's aid. So I said there'll be a little bit of a technical update amongst this as well. So here's a little bit of a technical update on the fungicide performance work. This is our Septoria data from the last, we haven't got this year's data, it hasn't been released yet. So the previous 3 years, 17 trials, so a large number of trials, all done in exactly the same way so we can be confident of the data. How do we interpret these? Well, here we've got our leading products. The latest Sarah, the new Syngenta product isn't on here, but it sits pretty much amongst those. Basically, everything's performing pretty similarly. Traditionally, perhaps a Dexar has been the leading product, but actually, when we look at large numbers of trials and we average them, we get very small differences. This is in a protectant situation, so before disease is established. Moving out to our solo products. Here's our solo SDHIs. Of course, you shouldn't be using those alone. They should always be used in a mixture. Performing very well. A lot of the activity which comes from these mixtures of azoles and SDHIs comes from the SDHI because our azoles, and these are our best azoles in Septoria, are not doing so well. Now, our two leading azoles, epoxyconazole and prothioconazole, depending on who you ask, they will say, well, which one does the best? Now, traditionally, we've said, actually, they perform very, very similarly. In one trial, one will do better, in another trial, another will do better against Septoria. In the last few years, we've seen prothioconazole just sneak a little bit ahead of epoxyconazole. That might be related to a specific mutation in Septoria, which seems to be appearing. I'll talk about that this afternoon. The other thing to note on here is Bravo, chlorothalonil. This is a litre of Bravo, half a dose. Look how well it does in a protectant situation. We talk a lot about using chlorothalonil in resistance management, but actually it gives you pretty good efficacy against septoria in a protected situation. If your timing starts to slip and you start to slip into a radicant situation, or when you're in a T2 situation, what you're doing further down the canopy, you're in a radicant situation. Sorry. The products start to pull a little bit further apart here. Maybe some of the newer products, Lebraxazole, it seems to be very good in a radicant situation. And Askra, the new three-way from Bayer. But again, there's not a huge amount of difference in here, but the products are perhaps pulled a little bit apart. What you'll also notice is in a radicant situation, of course, we get much worse efficacy. If you go back to 20 years when the leading azoles first came out, they would put the curves right down here. They'd give you 80–90% control in an eradicant situation. But at the moment, we have nothing that can do that. And as resistance has eroded the efficacy of those azoles, we've seen a very weak activity in the eradicant situation now. And the solo SDHIs, again, are doing a lot of that work over there. So you really don't want to be in an eradicant situation. If you look at the difference between the different products, and then you look at the difference between a protectant and an eradicant situation, timing is far more important than the product you apply. Quickly, yellow rust. As you might expect, the products, the SDHI azole mixtures, which contain all that, so that's an SDHI plus a strobe. But the ones that the SDHI azole mixtures, the ones that contain prothioconazole tend to be a little weaker because prothio is not so strong on yellow rust. Epoxyconazole is the strongest product. And we have some of the older chemistry still doing a very good job on rusts. So Comet, QI, Ignite, and Azole doing a very good job. And again, perhaps aviators thought to have been a little bit weaker on yellow rust, but actually in a program it doesn't show out quite so much as that. Barley, everything works on barley pretty much. Barley disease, or well, I'll come back to that in a minute. SDHI plus QI, SDHI plus azole doing very well. Proline has held up remarkably well against the barley disease. It's a very strong product against barley diseases, or it was. Imtrex, Floxaperoxad, very strong. There is a bit of a difference in the SDHIs in some of the barley diseases. That's something to notice. Within the wheat disease, the SDHIs are much more similar. In the barley disease, there is a bit of a differentiation. So Floxaperoxad does better than Vertisan and Zulu, the IZM from Syngenta. And Comet still gives activity on some of our barley diseases. Net blotch, everything works on net blotch, or used to work on net blotch. QOIs, azoles, SDHIs, all used to do a very good job. Now this picture probably doesn't mean much to most people in the room, but for the older people, the resistance is coming. We have resistance in barley, starting to appear in net blotch to SDHIs. In Ramularia, it's been resistant to QOIs for some time now, for a lot of years, but we are starting to see SDHI resistance and azole resistance starting to appear in Ramularia. Just in time for that, we are just, I'm not sure if it's hit the shops yet, but we have our new Ramularia identification field scoring guide. It was interesting at cereals this year. We had more questions about Ramularia in barley than everything else put together. It seems to be an emerging disease in barley. It's kind of come out of Scotland and is now sweeping southwards and affecting a lot of crops. It's not a massive yield robber, but it can come through very quickly at the end of the season and do some damage. So that's the cereal side of it. We do something slightly different with oilseed rape. We produce rather than just producing curves, we produce a narrative reports, or produce three narrative reports. The reason for that is because the oilseed rape results are a little bit more difficult to interpret. The reason being that there is generally more variability in oilseed rape crops, so you don't get that nice curve fit that you see in the cereals. So because it's a much longer season, the results you get can depend on when the epidemic comes in, whether it comes in the autumn, whether it comes in the spring, things like leaf spot. So the results are a little bit more difficult to interpret. So we produce these reports. There's a lot of words on this slide, but I will go through them because there are some important points. So for oilseed rape, in terms of FOMA control, thresholds are very important. I'll come back to that, determining when you apply. We have some really quite resistant FOMA varieties now. Sorry, FOMA-resistant oilseed rape varieties now. And some of those varieties do not reach threshold until late in the season, or they may not even reach threshold for treatment at all. But particularly in the south of England, traditionally people were focused on FOMA, but actually you need to consider light leaf spot as well. I mean, light leaf spot has moved up the agenda in recent years, but in those FOMA-resistant varieties, you also need to be looking for light leaf spot unless they have a light leaf spot high resistance rating as well. But as far as the fungicide performance is shown, over a number of years now, we've shown you can get good control of FOMA with a half dose rate program with 2 sprays in the autumn. You can get very good control of FOMA. Light leaf spot, on the other hand, has been much more difficult to control with autumn applied fungicides. And if you look at these curves here, we've got 5 trials here over 2015 and 16, and you can see no matter how much we apply, we're not getting any much more than about 50% control of light leaf spot. And you can also see from that, as I say, we get much more spread of points around our lines. We don't get such clean results with oilseed rape. Now, there is a school of thought which says for light leaf spot control, instead of a 2-spray program, we should be going on with a 4 or 5-spray program, going with a lower dose rate and hitting it multiple times. Not quite like we do with potato blight, but on multiple applications. However, most farmers don't want to be out in the winter spraying with a light leaf spot 4, 5, 6 times. They'd rather be out shooting. So we've tried to get research funding to look at whether that's a better way of approaching light leaf spot, but our crop committee, our research committee, who are mostly farmers, aren't very interested because they'd rather be doing other things in the winter. And with your light leaf spot, after an autumn spray, you really need to be looking for whether you need to spray in those crops again in the spring. So we're looking for reinfection in the spring. The good thing about oilseed rape is we have lots of different options. We have non-azole options, so we have SDHIs available now for light leaf spot, so we can do some good, and for FOMA, so we can do some good anti-resistance strategies there. Sclerotinia, generally speaking, dose is not that important, or product is not that important. Time is more important for sclerotinia. That doesn't always hold. If you've got very high disease pressure for sclerotinia, then product can become more important. But actually, in recent years, we haven't seen big problems with sclerotinia. We've had to shift our fungicide performance trials over to Wales in order to get sclerotinia, because in the traditional places we've tended to do them, places like Kent, where we used to get good sclerotinia results, we don't get them anymore. So sclerotinia seems to have, although it's still high in people's minds, we struggle to get results from sclerotinia trials. If you're going with high rates, you generally get about 3 weeks protection. Whether you need a 2-spray or a 3-spray, a 1-spray or a 2-spray program, depends a little bit on the season. I'll come back to that in a little bit. And again, there's a wide range of chemistry available for sclerotinia, and there are resistance issues with sclerotinia, so you really do need to address resistance in sclerotinia. And I've also mentioned PGR effects, particularly products containing tebuconazole and metconazole, so you need to be a little bit careful with those on oilseed rape. And make use of forecasts. Now, I know I said I wasn't going to say anything about resistance, but I'm going to talk about resistance monitoring. We do a moderate amount of resistance monitoring for fungicides. The main thing we focus on is an annual testing for insectoria, for azole and SDHI sensitivity. Some of that comes from our fungicide performance trials, and some of it comes from commercial fields. Keith at the back there very kindly supplies samples to this program from Velcourt. And we monitor shifts in efficacy. And you will sometimes see, depending on where you go, you'll see graphs like this, which take a bit of time to get your head around. It certainly took me a bit of time to get my head around. And so I'll just spend a little bit of time explaining what they show. Ignore the fact that it's hydroxyconazole, that's irrelevant. So what you have on the bottom is a concentration of fungicide. This is a lab test Concentration of fungicide is a log scale, which is worth noting. And here is cumulative frequency, so 0 to 100%. And each one of the points is an individual isolate that's been taken from the field, isolated from a leaf, grown up in the lab, and then tested. And if we look at these at different years, so if you look at this line here, this is 2003. So in 2003, here's our most sensitive isolate. It only requires as we move through the year, Septoria has become more and more and more resistant to azole. So this would be the same if we were using TEB, or we were using metconazole, or we were using thiaconazole. And the really interesting point here is, if you look at 2003, the most resistant isolate there, 2003, is basically the most sensitive isolate in 2016. So we've seen a shift in the whole population has become more insensitive to azoles. We also do a bit of ad hoc testing for fungicide resistance. This generally happens when we see some sort of shift going on. We want to investigate either we've seen in a commercial situation or in a fungicide performance trial. Because just because you see poor efficacy in a trial doesn't mean that it's resistant. It could be some sort of spray error, it just could be odd weather, as I'm sure you're aware. And an example of that, and you won't really be able to see it, I'm sure, is what happened in last year with net blotch. So this is what we used to see with net blotch, as I said earlier, pretty much everything controlling net blotch really well. And we had this trial in Norfolk, where all of a sudden, well, nothing did a brilliant job, but we had two products here, Imtrex, fluxaperoxide, and Vertisam, whose name I've forgotten just at the top of my head. The solar SGHI suddenly weren't doing very well against net blotch. We thought, well, that's unusual, because usually they're our best products. Here's Imtrex on this one, absolutely nailing net blotch, and all of a sudden it's giving us 30% control. What's going on here? So we took some samples, or we got in this case, NIAB, who were running the trial for us, to take some samples, and we tested them. We found that we tested about 35 isolates, and 75% of those isolates had a mutation to SGHI, one of these 3 mutations, and there was a clear relationship between the genotype, so the genes, and the phenotype, its resistance status, establishing that this was caused by resistance in this trial. And we put that information out to the industry and said, hey, look, we know this has been happening in Europe, we've now got it in the UK, you need to be aware of this and adjust your programs if necessary. We do still do some disease prediction in oilseed rape. So we have a light leaf spot forecast. I'm not sure if it's come out this year. I don't think it's out yet this year. So this is based on a number of factors, including things like disease on the crop at the end of the last season, rainfall, and it gives a preliminary forecast for light leaf spot, and that is updated later on. So this is just information. So if you're lucky enough to be in East Anglia, well, you think, well, light leaf spot isn't going to be such an issue this year, I can perhaps step back a little bit from the light leaf spot. But in the rest of the country, light leaf spot is going to hammer you, so you need to be right on top of the light leaf spot. FOMA is slightly different. FOMA is to forecast that when 10% of the plants will show symptoms, and that is your treatment threshold. So again, you can use this to say, okay, I need to start walking crops now and looking for FOMA because the crops in this area are about to reach threshold or close to threshold. So something to help back up what you do normally, your crop walking, your advice, just so to help you get a little bit ahead and help you with that work. And these are both available on our website. Then a little bit about some of the disease research that we do. Just a few examples of the type of thing we're doing now. So this is a project to look at, I said, Sclerotinia. A lot of people apply a 2-spray program, Sclerotinia, but actually you might not need one. You might need one, or you might not need any at all. So this is about trying to predict when Sclerotinia is going to be, risk is going to be high. They tend to be, because there tends to be over-application of Sclerotinia sprays, and this is about trying to forecast when you actually need them. Due to end in 2018, may become a commercial service. People have been trying to do this over a number of years with various different ways. Whether this morphs into a commercial service, we shall have to see. A similar sort of project, our arable crop disease alert system, and this again is based, is looking at sclerotinia, but also fusarium, because there's kind of no point in trying to predict outbreaks of septoria and yellow rust, because we know that they're all the time you have to treat for them. For things like sclerotinia and fusarium, where some years you have very bad epidemics, some years you don't have very much at all, it's worth trying to do a prediction. So this is based on spore trapping. So finding out when the spores are there, then using models to combine this information with forecast models for weather, and saying whether we're actually going to have a infection event in a local area. So here, ADAS High Mothorpe up in North Yorkshire, massive spike in spore release. So if that's combined with the correct weather conditions for infection, you need to get out there and spray. Due to finish again in spring 2018, and again it may develop into a commercial service. Keep an eye on that one. We've talked an awful lot about foliar diseases. We also do some work on soil disease. This is clubroot. Now, clubroot is one of those diseases which has kind of been happening elsewhere for a long, long time, and all of a sudden people are starting to find that clubroot is appearing on their farms. In some cases where it's never been seen before in recent years. And what this is trying to do is trying to predict areas where clubroot within a field and between fields is going to be a problem. So you can either treat it, you can grow a resistant variety, or you can just grow something else and change your rotation. So it's using a system to look at symptoms and then try and predict parts of the field where clubroot is a problem, or likely to be a problem. And if you look at this field here, where they did their test, they picked up this area where clubroot was likely to be a problem, and sure enough, when the yields came out, there was a clubroot issue there. Yields were heavily impacted. Obviously, you can see it's not quite perfect, but nothing's perfect. That was due to end in 2019, so keep an eye on that one, what it develops into, whether it develops into a useful test. So that was disease management. Moving on quickly to weed management. We only have one tool for weed management. We do much less work on weeds. We don't do any efficacy testing because there are no new herbicides. There are going to be no new herbicides, so we're not wasting our time with that. Our one tool is a Propyzamide decision support tool, because Propyzamide works very well in oilseed rape in controlling resistant blackgrass, but if you apply it when the soil is too warm, it will just volatilize and it won't do anything. So Dow recommend that you apply Propyzamide containing herbicides, and other herbicides from other manufacturers containing Propyzamide are available. When soil temperatures are at 10 degrees and going down, and you have sufficient moisture. So this comes from our weather station network. We have 30 weather stations around the country on RL sites, and it gives us a soil temperature and moisture level. So you can look at this and say, okay, what are soil temperatures doing in my area? Are they getting down to sort of levels where I can apply my Propyzamide? And if they are, go out and actually test in the field. This isn't designed for you to say, okay, AHDB says I should apply. You then go and test the soil yourself. And Dow's have a postcode system as well. But you really should be testing the fields you're going to spray. Weed research. We focus on grass weeds for obvious reasons. It's our main focus of research, and we spent a lot of time looking at glyphosate in recent years. In 2015, because of issues not with losing glyphosate to legislation but resistance, we produced, in combination with the Weed Resistance Action Group, these guidelines for minimizing the risk of glyphosate developing in grass weeds. And that basically came down to 4 actions. Prevent survivors, so if something survived the glyphosate, because it has any level of resistance, you've got to kill it some other way, generally by cultivation or possibly another herbicide. Maximize efficacy, don't cut rates of glyphosate, very bad, don't do it. Use alternatives, cultivation or alternative herbicides, and monitor success. So if you put glyphosate on and you're not getting control, why is that? Was the rate too low, or the conditions wrong, or are you getting resistance? And if you think you're getting resistance, get it tested, because we need to be on top of it straight away. When we put those guidelines together, it did throw up a few gaps in our knowledge. And so we developed a project to look at those gaps in knowledge, run by ADAS, but supported right across the industry, both by distributors and manufacturers, because we all know the importance of glyphosate to the industry. And one of the early results from this was basically ADAS went and asked all these people for their trial results on glyphosate to ask the key question: how many applications of glyphosate do you need to put on blackgrass in order to get good control in the following crop? And from 113 trials that we conducted over a lot of years, they showed that actually you can get pretty much all your control from 2 applications. If you go to 3, you get a little bit more control, but you do hear of people putting this sort of numbers of applications of glyphosate on to try and get control of blackgrass. So you spray, you let it chip, you spray and spray, but actually you don't get any more control in the following crop. And this is just like to drive resistance. So 2 applications of 540 grams per hectare. That's if you're up to grow, say, 13. If you get slightly larger plants, then you need to up the rate a little bit. And that project is ongoing. There will be a lot more come out of that. Another project we're supporting, we're only 10%. This is a BBSRC project, so we're putting £280,000 into it. It's a big project, 2.8 million. And this is looking at how blackgrass resistance is spreading and how management impacts on that. And you may think, well, blackgrass is resistant already, it's a waste of time. But actually, when they looked at resistance to ALS inhibitors and ACCase inhibitors, what they found was, yes, in those core areas, so this sort of part of the country, very high levels of resistance. But even in those core areas, there was some population of blackgrass that was still susceptible to either ALS and ACCase inhibitors. But once you go out of those sort of core areas into Norfolk, into Yorkshire, then the level of resistance is still, well, relatively low compared to the core areas. So if you're working in these sort of areas, then actually it's still worth getting resistance tested to know what you're dealing with, so you can use the appropriate chemistry and not drive resistance any further. And they also tested these populations. Each dot is a population they tested against glyphosate. And the blue dots are the good ones, because that shows that glyphosate is doing its job. But you may or may not be able to see there's a dot about there and a dot about there, where the level of control from glyphosate was much lower than you'd expect. And the results haven't been released yet, but this work is showing that where you apply more glyphosate, or where more glyphosate has been applied historically, the level of sensitivity to glyphosate in blackgrass is lower. So basically it's saying, if you keep applying more and more glyphosate, your blackgrass will become less and less sensitive. And we are at a point now where some populations of blackgrass in the UK are very close to being resistant to glyphosate. So glyphosate is very cheap, it's very good, but we need to use it sensibly so that we don't lose it, because it's very cheap and it's very good. I'm not trying to scare you. Bromes going to be the next weed problem. There seem to be an increasing number of reports of difficult to control brome populations in the UK. This could well be reduced tillage. We know that ploughing is very good for bromes, minimum till, no till, bromes love it. So it could be tillage. It could be reduced use of post-stem herbicides. People who aren't applying Atlantis or other very effective, well-known post-stem herbicides to their blackgrass because it's resistant, they're now not getting control of their bromes. They were incidentally getting control of bromes before, but perhaps it's because they're not applying those post-stems, or it's giving the bromes space to grow. So is it resistance, or is it just different? I've put poor management, that's not really fair. Is it just that management has changed and that's left a space for bromes? You can find out in this afternoon's resistance workshop. It's very early in the project, so we don't really know yet. Broadleaf weeds, we've focused mostly on raising awareness and resistance in broadleaf weeds. They're not a huge problem yet, but the problem with broadleaf weeds is cultural control options often don't work very well with broadleaf weeds. Some have very wide germination windows, for instance chickweed, so there's no point in changing your drilling date or have any effect. Some, like poppy, have very large or very long-lived seed banks, so you can't run down the seed bank. And in terms of globally, we've got a lot more herbicide-resistant broadleaf weeds than we have grass weeds. And this is the sort of thing we can get. This is an extreme example. This is a site in Cambridgeshire where the poppy is ALS resistant. So you apply ALS resistant, it doesn't touch it. Fortunately, within broadleaf weeds, we still have quite a lot of chemistry that works. So if you put in a non-ALS program, you get good control. But this program costs about 4 times what this one costs. So there are issues going on in broadleaf weeds. They're not widespread yet, but you need to be aware of them. And there seems to be some up-and-coming issues with broadleaf weeds, becoming more problematic. Crane's bill, charlock and oilseed rape, and wild carrot apparently is becoming more of an issue. So things to keep an eye on. And everyone else has mentioned Brexit, so I'm going to mention Brexit. If the way farmers are paid in terms of subsidies changes, and there's been a lot of talk about having much more green subsidies, so have to pay farmers to do things that we want, whether that's growing skylarks or weeds or whatever. Weeds may become more valuable to you as agronomists and to your farmers you serve. And not all weeds are bad. Some of these less competitive ones don't really do very much. You don't need to control them that much. Some have good wildlife attributes. And some are both not competitive and give good wildlife value. So you may need to change your attitude to weeds slightly in the future. I won't say very much about this because it's been covered elsewhere, but keeping in touch, Agronomist Conference is where the first view of the new fungicide performance data comes out. So I'd urge you to come to that. There's going to be some interesting results this year around resistance. Other events, our research outputs, our website, and the monitored farms and the star farms, again, they've all been covered, so I won't say any more about those. And that's all from me.